Hi friends, welcome to Chemistry Academy, and now we will talk about commutators. So look, commutators are basically operators, but what type of operators and what the relationship is found between these operators, we have to study about them. So look, a commutator basically is a mathematical operation in which we interchange the position of operators. So if the result is not affected, then they are called commit operators, and that phenomenon is called commutators. That operation is called commutators. So basically we will divide them in two parts. First of all is commit, and the second one is non-commit. Now look, what the mean of commit is like husband-wife relationship. Whatever will be, but we will live together. That's the basic fundamental theme of commit. It means if I say A and B, the two operators, is equal to BA. It means after interchanging the position, their values remain same. And that's why it's called commit operators. Now non-commit. It means simply I will say AB is not equal to BA. It means whenever I will change the position of operators, the value will not remain same. So that's why it's called non-commit operators. So this is basically we have to study about commit and non-commit further. So now we will take examples and we'll try to understand what kind of example, what kind of questions is asked in our exam and how to solve them. So let's study about that. Now basically this is the example, okay, and we have to apply mathematical operation on this example and we have to get the result, and that's when we will further divide them if it is commit or non-commit. Okay, so now how to solve them? Okay, first of all we have to remember that one particular condition for commit. What will say? AB is equal to BA. Okay friends, that's the basically condition for commit operators. Okay, so now if I write is this like AB minus BA is equal to 0, that's also a right form. Okay, so now just apply this condition on this example. So first of all AB, so if I assume this is A and that is B, it will be written as x d upon dx. Okay, and then further we have to interchange the position. So now B will take the first position here, d by dx, and then the second one is here, x, and we have to apply a mathematical operation. That's why we have to remember the trident. The trident is the operation factor. The trident is the operator factor. So it will operate then. So we have to remember in any question of operators, this trident, it means this psi will occupy its respective position always. For an operation, a trident is used in quantum. Okay, so now let's simplify it. As you multiply, it will be written as x d psi upon dx and minus dx psi upon dx. Okay friends, it will be written like this. And now we know that from differentiation it will be written as psi dx upon dx and x d psi upon dx. Okay, so look, it will be written as, and both are same but opposite in sign, so we'll subtract each other and cancel out. Okay, and the remaining will be minus psi, and that results into 1. So minus psi is resultant, and after operation the trident is removed from the example. As we know, we have to do it. Okay, now minus psi, so basically when we will remove it, it will be written as minus 1, because the multiplication factor is here is 1. Okay, so minus 1 is remained. So now look, what is the condition for commit operators? AB minus BA is equal to, should be 0. But here when we did xd by dx minus dx by dx, what the answer is minus 1. So that's why we will simply say they are not commit. They are not commit, they are anti-commutator. Okay, because we got minus 1 here, so I'll simply say they are anti-commit. That's the answer, that's the relationship between them. Okay, now we'll take further an example and we'll get the relationship. Now I have written the new example, but look, at the first example we took x at first position and d by dx at second position, and the result will be minus 1. Now just remember it, when we will take it first and x at the second, the result will be 1. Okay, and we know that the condition of commutators, the commit operators, is AB minus BA is equal to 0. Even here is not 0, so that's why it is also not committed. It is also not committed. Now look, the funda, the basically the trick to remember it, I will say x means x girlfriend, and this is d by dx. When girlfriend is x, what comes in life? The negativity. So that's why basically the trick is, we will remember it is the negativity and 1. When girlfriend is x, what comes in life is negativity. So in this way we will remember, whenever x is first, the sign will be minus and it will be minus 1. And then if it is taken as first, the answer will be 1. Okay, and we can simply remember it, the opposite of this first example is the second example. Okay, now we have to make it simple and sober tale based on these examples. quantum is very simplest unit of physical chemistry, provided we follow the path of tricks. Okay, now look at the board. X d by dx. We know that when girlfriend is x, what comes in life is negativity, so -1. Now based on this example, I'm writing this x square d by dx. So just remember the basic formula. Minus is right here, and what we have to do, n x power n minus 1. We have to do the basic differentiation formula here. Only just to remember this negative sign. Now, what is the differentiation of x square? It will be 2x 2 minus 1. Then the resultant will be minus 2x. Okay. Now further I will take x cube d by dx. The resultant will be simply this differentiation formula will be applied here, and it will be minus 3x square. So we will do this same applying this formula. Okay, so I can written this if it is x and d by dx, it will be n x and minus 1, and the negative sign is here. Okay. What if I interchange the position? It is taken as the first and it is taken as the second respectively. So as we know that when we take d by dx as the first, the result will be same but opposite in sign. So just look, d by dx and x, the resultant is 1. So what if I take d by dx and x square? So simply the differentiation formula nx n minus 1 we will apply here. It is a tricky manner to remember these commutators. Now x square, so it will be resulted as 2x. What we have to do, simply we have to remove this negative sign, and the resultant will be same as we previously discussed. So I will written as d by dx x power n, and now it will be written as n x power n minus 1. Okay. So what we studied? We studied basically two commutators here, x power n d by dx, and it will be opened as minus n x power n minus 1, and the opposite of this, so the resultant will also be opposite. Now we will take the next example. Now this is the third example, and look how simple it is. What we have to do, just to remember the basic tricks of quantum, what I have told you, basic tricks, and how easy it will be. Look at the board. It is the linear simple momentum operator. Okay, and x. How to solve it? As we know that px is further written as minus iota h cross d by dx. Okay friends, we will write it like this. Now x minus iota h cross d by dx. The simple way to solve this, we will take it outside bracket minus iota h cross and x d by dx. As we know that when girlfriend is x, what comes into life? The negativity, minus 1. We have discussed previously, the result of this is minus 1. So minus 1 here and minus iota h cross. The minus and minus will be plus and it will be iota h cross. So the commutator, the result of this operation will be iota h cross. We will take into consideration cos. We have to take next examples based on this commutator. So iota h cross is the result of x px. Iota h cross. It is to be remembered. It is to be remembered and it is very important for part B in CSIR net and the questions which have marked as 1 number in GAT. It is very important for their questions. Now, the next example, it will be based on this example number 3rd, and we will take it into simple way. So look how I solve it, and you will solve all other examples same I solve. Now I take x square px. You have to write the basic trick here. What is that? Iota h cross is remain here and n x n minus 1. Where it is taken as a square or cube or further powers, it will be written as iota h cross n x power n minus 1. So now, what is the result of this? Iota h cross 2x 2 minus 1, so it will be 1. So simply I will write it 2 iota h cross x. Okay, 2 iota h cross x. And if I take x cube px, what will be the result? 3 iota h cross x square. We will apply this formula here and we get the result. Now, what if I interchange the position? Look, we have to remember key points, and these key points will help us to solve these complicated examples through a simple way. Now what if I interchange the position of these operators? I interchange the position x. So I know that the answer of this operation is iota h cross. And what will be the answer of this? We'll derive it iota h cross minus iota h cross d by dx and x. As we know that dx is written as minus iota h cross d by dx. So it is written basically Now I will take iota h cross minus iota h cross outside the bracket. And what is the result of this operation is 1. So basically what I got is minus iota h cross. So I will write the result of this operation is opposite of this minus iota h cross. So simply, if I increase the power, if I take x square, it will be minus 2 iota h cross x. The basic formula you have to remember, and we'll apply here minus 2 iota h cross x. So the basic formula I will write for this minus iota h cross and x power n minus 1, and for this iota h cross and x power n minus 1. Now I will move on to the next example. As we know that the resultant of this operation is iota h cross. Okay. What if I increase the power of px as px square? Now a short change I have to apply here. Look, iota h cross will be remain here, and I will say iota h cross and px and minus 1. Now the simple basic differentiation formula will be applied on simple momentum operator. Iota h cross and px power n minus 1. So iota h cross here, and the power is 2. So 2 iota h cross and 2 minus 1. So it will be 2 iota h cross px. Now what if I interchange the position px square x? So the result will be same but opposite in sign. So it will be written as minus 2 iota h cross px, and the basic formula will be minus iota h cross and px and minus 1. So these are the examples of commutators. Now based on these examples, I will solve some questions. Now I will solve these examples one by one. So look, I am solving first 2x square d by dx. So what I will do, I will do something changes here. This 2 will be written outside the bracket, and x square d by dx. And previously what we have discussed, it will be written as minus 2x. So what will be the result? Minus 4x. Okay. How I solve it? It is minus n x and minus 1. So the resultant will be minus 4x. Now this second example, simply I will take it outside the bracket and x square px. And what is the answer of this? It is written as 2 iota h cross x and 2 is outside the bracket. So answer will be 4 iota h cross x. Okay. And the basic formula of this is iota h cross n x n minus 1. Okay. Now the third one, I will take it outside the bracket and it will be written as 3 iota h cross square. So 6 iota h cross x square. So we have discussed so many examples on commutators, and we will further discuss many examples on commutators. So stay tuned with me. I will be right back in next class.